dv equal cosine x dx. And now I'm going to walk through the process. du is equal to e to the x dx. V is equal to sine x. I'm hoping this isn't too bad at this point. Nothing too fancy. I'm going to do the process again. And this is only going to pertain to that. So this second by parts is only going to pertain to the underlying red part.
Mr. Ryan, why did you let dv equal e to the x dx, not sine x?
If I'll get to that. Yeah, I'll exactly mention it here in a second. I did exactly that teaching it once, and it really came back to bite me. And you'll see why. I'm going to clean this up a little. Wait, just get comfortable here. Again, if you guys need to migrate over to my desk, then
Could I sit at your desk?
you certainly can. As long as you're kind of hunched over.
And you don't get in my way.
Yeah. Go the way the camera is.
Yeah, shift it to the right a little if you can. There you go. Just like, there you go.
Yes. So one more time. I actually have three. I have 1, 2, 3.
Okay,
Missing a negative where? After the integrals. You mean here?
yeah. No.
So I'm seeing this becomes plus here. And then we get the minus here. Now, it looks like our situation has not improved. In reality, it actually has. What's all this equal to? What did I start out with?
Oh. That's very interesting.
I'd like to point out that that and that are like terms. So what do you think I'm going to do?
Cancel mine.
I'm going to add it to both sides. We're done with that then. me here.
So you just divided the two
That
out
is
and moved
because
to the other
I
side?
had to. Second, we're here. I had to multiply, this is u times v here. U times v, and there's my negative. That's fine. This times this. Doing math at this level requires you to have a certain level of organizational skills. I don't know about you, but when I first started doing this, I was so disorganized, I couldn't keep anything straight. And I just kept asking the same questions over because so my point is, what you're going to need to do is figure out a way for you to organize yourself, whatever that means, so that you can eventually produce a product that I can follow as we go through this. So, you guys understood that divided by 2? Mm-hmm. I don't need to write divided by 2. Mm-hmm. Then I factor the e to the x out. Now, doesn't the plus c get divided by 2 as well?
No.
Yeah.
Oh, it does?
Yeah. But a constant divided by 2 is still a constant, right? So we're going to abuse that constant notation actually a lot this semester. I had a student, he had some sort of, I don't want to say disorder, some sort of brain something going on, and he had to keep track of every single constant. He did subscripts. I remember one of them, there were 13 subscripts, C sub 1, C sub 2, C sub 3. And he kept track of the whole thing. Please don't do that. Questions here? Yes, sir.
So, Vern, when I took that differential, we had to have all the subscripts.
Now, those you have to.
Yeah.
That's different. Yeah. So there are times when you do have to keep track of them, because you have to go back eventually, and it ends up being like a system of equations that you have to solve the whole thing. All right.
No.
Any questions here? Yeah.
Why is the C there at all? Just like in the book.
I don't have to take it.
No, the initial formula, there's no C, but after you do the integration, you end up with the C for sure.
I could.
Anybody?
I don't have to.
Questions?